for being able to solve polynomial equations later on. The greatest common factor is the biggest thing that we can divide everything by. Okay? So, if we look at this first problem, let's just look at the coefficients first. Who can tell me what a coefficient is? It's the big number, right? So the coefficients are the big numbers out front. If I look at 3, 6, and 12, what is the number that I could divide all of those by? 3, right? So here, I am wanting to divide all of these by 3 because it is possible. Okay? Then, they all have x's with them, right? How many x's are there in this first term? 3. How many in the second one? 2. And in the last one? Doesn't have one written, but there's just 1 right there, right? So, you can also divide by the lowest number of x's. So, our lowest number of x's would be just 1x in this case, right? So, I'm going to put an x with all of these. So, my greatest common factor here is 3x. Okay? So, I am trying to keep this equivalent. I want it to still match, right? So I'm going to write my 3x out front, and I'm going to have a parentheses right here. Okay, so I'm going to go through, and I'm going to divide each one of these. So 3 divided by 3 is, oh, excuse me, 3 divided by 3 is 1. Okay, how many x's? There's going to be 2. When you divide x's, what you're doing there, you got 3 x's on the top, you got 1 on the bottom. If you got an x on top and bottom, they cancel out, so you just have 2 left. Essentially, like where we're dividing by a single x, we're just like taking 1 x away from everything, right? Okay, 6 divided by 3, 2. So we got minus 2. How many x's are going to go with that one? Just 1. And then 12 divided by 3, 4. And how many x's go with that one? None at all, because they just cancel out. This 1 that I have written right there is not necessary, but if you write it, I'm not going to be upset with you. Now, we can use Desmos to check to see if we have done these correctly. Let's see, let me do it this way. Let me put Desmos right here. All right, so now it won't tell you if you factored completely, but it will tell you if you've messed up. So if I do 3x to the third minus 6x squared plus 12x here, okay, so that is my original function. And if I do 3x times x squared minus 2x plus 4 here, I should see that they're the same graph, right? So even though I can't see it very well, I can see those there. If I click here, the line just turns blue and green. That's the same graph, right? If you, like, let's say we left the x right here. Notice how those are not the same. That would be like, uh-oh, I've messed up, right? So while Desmos will not do this for you, it will help you check your answers for this, okay? Okay, questions? Now, this is still equivalent to this because if I multiply it back, 3x times 1x squared gives me 3x cubed. 3x times 2x, negative 2x gives me negative 6x squared, and 3x times 4 gives me 12x. All right, so that is correct. All right, questions on that? All right, what is your greatest common factor for number 2? Okay, as far as the numbers go, you've got a 1 right here. So 1, 8, and 12, 1's the only thing you can divide by, which really isn't going to like change anything, right? How about the x's? You can take 1x away because there's only 1x right here. So essentially you're just taking one of the x's out. You can put the 1 there if you want, but you don't have to. If I had 4 x's and took 1 away, that means there's 3 left here. 8 divided by 1 is just 8. It stays the same. I had 3 x's. I took 1 away. I'll have x squared. And then here, 12 divided by 1 is just 12. Stays the same. I had 1x. I took it away, so I've got no x's left. Okay, questions? All right, number 3. I've got 10 minus 15x squared. Okay, what number could I divide both of those by? 5. All right, what about the x's? Okay, take any x's out? Do you have any x's right here? You do not. So you can't take any x's out on this particular problem. Because if you have a term with no x's, then no x's can come out at all. So if I put my 5 out front, 10 divided by 5 is 2. 15 divided by 5 is 3. And then that x squared just stays the same because we didn't take any x's out. Again, I can check this. Like if I'm not sure if I'm doing it right, go over to Desmos, type in what you started with, 10 minus 15x squared, and then type in what you ended up with. Ooh, go to the second line first, and then do 5 times 2 minus 3x squared, and you can see there it's the same graph, so you know that you've done it correctly. If you mess it up, like for example, if you've got a 4 right here, you'll see they're not quite the same graph. They're close, but if you zoom in enough, they're not the same graph, so that would let you know you did something wrong. There. Okay, Josiah, what can we divide by on example 4? Okay, 4 for sure. What about x's? Can we take any x's out? How many? 2. Good. You're going to take the lowest number of x's. So that would be that last term only has 2 x's. All right, so make sure whatever you're dividing by has to be written out front. Okay? 16 divided by 4 is 4. X to the 4th power. If you had 6 x's, you took 2 away. Now you've got 4 left. 8 divided by 4 is 2. You had 3 x's. You took 2 away, so you just have 1 x left. All right, what am I going to get on that last term? I get a 1. Make sure you write that 1. A lot of kids just like cancel that out and don't put anything. That will not be correct on that because 4 divided by 4 is 1, and then the x's cancel on that. And again, you can use Desmos to check to make sure you did it correctly, or at least to make sure you didn't mess up. 16x to the 6th minus 8x to the 3rd plus 4x squared. And then down here, we got 4x squared times 4x to the 4th minus 2x plus 1. And you can see those two are the same graph. Notice what happens if I forget that plus 1, the graphs don't match anymore, right? So it's a good idea to type it in to check to make sure you're doing it right on those. Plus, if you see these as multiple choice, you can just type answer choices in to see which one matches. And you'll see something like that. Okay? All right, questions? All right, greatest common factor is the first thing you're always going to do. All right. So, I meant to go look this up. I might have to because I always forget. I don't do it this way. I never do it this way. I don't really like it, but I think it is going to be the way you have been taught. So, factoring binomials or trinomials, particularly trinomials, is what we're going to look at here. That is when you're wanting to take something like x squared minus 9x plus 14 and break it up into 2 sets of parentheses, like that. And you might have x plus 4 and x minus 7, or something like that. That's not it for this one. But let's see. How many of you had Coach Wood for Math 1? There's only a couple of you, right? And then how many of you had Miss Martin? Most of you. And then a few of you were not here, and a couple of you had me. I did not teach X method. I don't love it. But I think Coach Wood and Miss Martin taught you the X method of factoring, where you did like this, and you had Have I forgotten how to do X method? Do you guys remember how to do X method?
Oh.
Okay. I should have looked this up. Even though, if y'all don't remember it, that proves my point that it'll help you a little while you're doing it, but it doesn't really stick that well either. If you remember doing X method and you liked it, you are welcome to use X method, and I'll go back and look up how to do it. I think it's like I just do it the other way. Okay, so I'm gonna teach you guys the way I teach factoring in Math 1, but I'll go back and look at X method and show you a couple of those in case that like jogs your memory and you'd rather do it that way too. What we're looking for is to break this up into two sets of parentheses, right? And so if I multiply those parentheses back, it should give me x squared minus 9x plus 14. We might need to make sure you guys can do that first. Maybe on the side right here. Even though I guess I'm going to do it over here because I am videoing and there's several out. Yes? Okay, tell me. And you do them like right here. Yeah. Yeah, you're right, and those are the right numbers. Do you remember how to do it when you got a 3 up here? Like on the second one? I think you got to do like 3 times negative 8. I can't remember. I got to go look it up. I'll go look it up in a minute. And what I'm getting ready to teach you is essentially the same thing that Alex just said, if you remember the X method. So, but first, let's make sure you guys know how to do this. So this is like a side note. This is not to multiply binomials. If I want to multiply something like x minus 3 times x plus 6 together. Okay, how do I multiply those together?
You would bring
You're distributing is essentially what you're doing. I usually start with this x right here. You might have been taught to. Have you ever heard like to FOIL, first, outers, inners, last? I don't do that much anymore. But either way, you're just taking the x, you're distributing. What is x times x? It is x squared. X plus x would be 2x, but x times x is x squared. So x times x is x squared. Then you have to distribute your x over here to the 6. So that would be x times positive 6, which would give you positive 6x. Right? Okay? But if you just stop there, you didn't do anything with your negative 3. So you have to take this negative 3 and you also have to distribute it. So negative 3 times x is going to give me negative 3x, and negative 3 times positive 6 is going to give me negative 18. We all right there? Then, do I have anything I can put together? Negative 3x and the positive 6x can go together. I will have x squared plus 3x minus 18. Okay, so that is how we multiply binomials together. Factoring is like breaking them back apart, right? We're trying to like get them broken back apart. And the reason we would want to do that is because it is helpful for solving equations. Because of the zero product property, which we'll talk about later. If I want to factor this, notice right here, when I multiplied the first number times the first number. And that gave me x squared, which was my first number that I had in my expression, right? So, when we're factoring, we want to do, we want to try to get the first term right here to be x squared. What two things can I multiply together to get x squared? X and x. That's really like my only real option, right? So I'll put x here and x here. It's much easier to factor whenever you don't have a number in front of your x, right there, okay? Now, for my last term, notice here, when I did this, when I did, I wish it would let me change colors, but it's not, just is always yellow. So when I multiply the 3 and the 6, it gave me negative 18, which ended up being the last term, right? So whenever I multiply these two numbers right here together, it's going to give me that last number, which is a positive 14. What numbers could I multiply together to get positive 14? 7 and 2. I could do negative 7 and negative 2. And notice this is pretty much the same thing with the x method, right? There. What else would work? 14 and 1. Or I could do negative 14 and negative 1. Okay? Because I have a minus 9 right here, do I need the positives or the negatives? I'm going to need the negatives because if I have all positives in a problem, the negative's not going to show up anywhere, right, to get that negative 9. So this one's not going to work, and this one's not going to work right here. And then whenever you just have x's right here, you can do, like Alex was telling us, we want to see which one will like add up to give us the negative 9, right? Which one of these adds together to give you negative 9? Negative 7, negative 2. So we can put negative 7, negative 2. And then to check it by hand, we would just multiply it back together, x minus 7, x minus 2. So to multiply those together, we do x times x, which is x squared, x times negative 2, which is negative 2x, negative 7 times x, which is negative 7x, and negative 7 times negative 2, which is positive 14. And then if we put those middle two together, that's x squared minus 9x plus 14, which is, in fact, what we started with, so we did it correctly. Now, the answer is this, x minus 7, x minus 2. That's your answer right there. Does everybody at least remember having to do this? Not how to do it necessarily, but having to do it before, okay? So you do it in math, you start doing it in math 1, you do it again in math 2, here we are in 3, doing it all over again. All right. So let's factor one that is a little bit harder, okay? So I'm going to do it the same way we just did it, but when you have this number in front of the x squared, you're going to have to do a little bit of guessing and checking, okay? So, first of all, the first thing we always want to do is look for a greatest common factor. Do I have a greatest common factor? Is there something I could divide all those by? Oh, wait, hold on. Let's pause. First, I need to make sure I did this correctly on the last problem. Desmos will not do this for you, but it will tell you if you mess up, right? So, if I type my original in, and I type in x minus 7, x minus 2, it should be the same graph, and it is, right? Like, let's say I accidentally used plus signs instead of minus signs, not the same graph. If you see that happening, you know you messed up, okay? So if you graph the original and your answer, they should still be the same for that. So, I've got 3x squared minus 2x minus 8. We're wanting to break this into two sets of parentheses. And in this sets of parentheses, we got, these are binomials. We got two things. To get that first term, our first term is 3x squared. What could I multiply together to get 3x squared? What? 1 times 3. And they'll have to have x's with them, right? 1x times 3x. That's pretty much your only option. You could make them both negative, but I'm going to tell you, don't ever make the first term negative. It just makes it complicated to deal with. So I'm going to put a 3x right here and just an x right here. You can put the 1 with it if you want. There, this means the same thing. Thankfully, that is my only option there. So I don't have a bunch of things to try. Sometimes you have more than one option for that first term. All right. What about my last term? It is negative 8. What could I multiply together to get negative 8? Negative 2 and 4. I could do positive 2, negative 4, right? What else? Negative 1 and 8, or positive 1, negative 8. I think that's all my options here. Now, I want a negative 2 in the middle. There is one of these that adds up to be negative 2. But, let me warn you, it's not the same when you have this number in front of 3 right here. If you use my method, you have to guess and check. And then I'm going to go back and see if I remember how to do X method. And I'll show you, there's less guess and check, but the numbers sometimes get big when you do X method. So, like I might see, oh, that gives me negative 2, so I might try it. So if I do plus 2 minus 4, like that. Here's the problem. It doesn't always work. If I multiply this back together, I would get 3x squared minus 12x plus 2x minus 8. Now, my 3x squared is correct. What am I getting in the middle, though? Negative 10x. And then my minus 8 is correct, which it should be because that's what I picked numbers for. But does that give me what I'm supposed to have? It does not. So that did not work for that. So that particular one doesn't work. So I'm going to have to go back and try again. And unfortunately, my stupid eraser does not work. Will it let me? And it doesn't go back either. This will turn into a mess. Also, this is, if you're using a pen, you're going to use a lot of paper for this. I would suggest a pencil on these problems. So let's say, before we give up on 2 and 4, sometimes it helps on these problems just to switch where they're at. So if I make this right here a 4, and I make this right here a 2. Okay, sorry for all my crossing out. This is the best I can do. All right, so now if I multiply 3x times x, I get 3x squared. That does not change. 3x times negative 2 is going to give me negative 6x. And then positive 4 times x is going to give me positive 4x. And then positive 4 times negative 2 gives me negative 8 right there. What does negative 6 and positive 4 give me? That gives me negative 2x. Is that what I want? Yes, that matches what we have here. So the correct answer for this, I'm going to write it over here a little cleaner, 3x plus 4 times x minus 2. Or you could have them in the opposite order. It could be x minus 2 times 3x plus 4. It doesn't matter there. If we check to make sure we did it right with Desmos, it looks like this. We type in our original 3x to the second minus 2x minus 8. And then we go over here and type in our answer, 3x plus 4. Oh, get rid of that. 3x plus 4 times x minus 2. And you can see they're the same graph there. So that lets you know that at least you didn't mess up on it. Sometimes you may have missed the greatest common factor if you do it that way, but you have not got it 100% wrong. Okay. I'm gonna look at X method, but it's, well, let's see. Let me go back. If I do that same problem with X method, let's see if I can remember it. Okay. If I do that same problem with X method, this is the one that's a little bit different on. Make an X. I'm pretty sure you take 3x squared and negative 8, and you multiply those together to get a negative 24 on top. And then you're going to put the middle term goes down here on the bottom, which is your negative 2. And you want to multiply to get this number, right? And add to get this number, right? So this one's not too bad, but you do have the numbers get a little bit bigger on this, because if we're thinking about what we can multiply to get negative 24, what could we multiply to get negative 24? Negative 6 and 4. I could do negative 2 and 12. I could do negative 1 and 24. I could do negative 3 and 8. Okay? So, when I do that, I want to look for the ones that add up to give me negative 2. And I also could have, I guess I should list these. I could have positive 6, negative 4, positive 2, negative 12, positive 1, negative 24. When you get good at this, you can just do this part in your head. You don't have to list it all out. And the negative 6 and positive 4 are the ones that give me this. So I have negative 6, positive 4. Now, the trick for X method is that at the end, you have to go divide by this number right here. So we got we divide by 3 right there. And so for this part, 6 divided by 3 is going to give us negative 2. And so that's where we get an X minus 2. This one won't divide, right? So this is where we get our 3x plus 4. Is that what we had on the other one? Yeah. And so that will, like, whatever's on the, if it reduces, you reduce it. If it will not reduce, whatever's on the bottom, you put it first. Whatever's top goes here. I don't love this because it's just a trick that does not show you understand how to multiply it back together very well at all, but I'm perfectly happy with any way that you can get the correct answer, and totally willing to let you do it that way if you like it. I know some of you probably learned it that way, although I don't know that too many of us remember it. So, okay, let's look at this one. Okay, this one is a little bit different because this one only has 2 terms, which makes it a binomial. What is missing here? A number for the x in the middle, right? So what we want to do when we're thinking about these problems is we're thinking of it this way. X squared plus 0x minus 25. So that number in the middle needs to be 0, right? We wouldn't ever write that because 0 times anything is just 0. But that's what we're thinking of. Otherwise, you do it pretty much the same way. Okay? So we're going to do 2 sets of parentheses. The first term for this is just x squared. What do we multiply together to get x squared? X times x. So we got an x here and an x here. Right? That's definitely what we're going to use. You don't have to think too hard about that. You probably don't really need to write it down, but you can if you want. For our last term, we want to get negative 25. What numbers could we multiply together to get negative 25? 5 and negative 5? Right there's it, right? You also could do 1 and negative 25. You could do negative 1 and positive 25. I think that's it for those, right? Which one of those is going to give you 0 in the middle? 5 and negative 5. So we would have a plus 5 and a minus 5. Now, when you see a problem like this, it always ends up being the two numbers that are just opposite of each other, right? Because it takes a positive 5 and a negative 5 to make 0. No other combination is going to give you 0 for that. This particular type of expression shows up a lot and has a special name. It is called a difference of squares. Okay, and it's called that because both of these numbers are perfect squares. You can take the square root of them and have a minus between them, which makes them a difference. Okay. So, let's see. All right, let's do, let me pause for a second here. Let me see what I put on the assignment. Okay, now we got to do a couple of these before you can do some work. Okay, so if you see something that asks you to factor completely, that means that you need to break it apart as far as it will go. The first thing that you always look for is the GCF. Does number 7 have a GCF, the greatest common factor? Okay. 2, what about x's? Can I take any x's out? All right, 2x squared is coming out of all of these, right? When you do this, make sure you write the 2x squared out front. Okay? 2 divided by 2 is 1. You can write it if you want, but you don't have to. And then you had 4 x's. You took 2 away. You've got x squared. All right? 16 divided by 2 is going to give me 8. You had 3 x's. You took 2 away. You just have an x there. And then the last one, 18 divided by 2 is 9. How many x's with that one? 0. Now, this problem, if we want to like check and see if we're doing it right, if we pull up Desmos and we type in 2x to the 4th plus 16x to the 3rd minus 18x squared, and we type in what we've got right now, 2x squared times x squared plus 8x minus 9, we can see they are the same. This does not tell you you're done. It just tells you haven't messed up, right? Because we're going to do some of this assignment on Delta Math, and if you type this into Delta Math, it's going to tell you you're wrong. It's not going to give you, it's not going to tell you it's right, because you could factor this more, okay? So let's look at what to do to factor it more. The 2x squared has already came out. It's going to just kind of hang out front. But this middle part, we could factor into 2 sets of parentheses. Okay? Now, this 1 that I have written here is not really necessary. What can I multiply to get x squared? X and x, right? So the first terms we have in each one of these are going to be x and x. For that last term, we got negative 9. What numbers can I multiply to get negative 9? Negative 3 and 3. What else? Negative 1 and 9. Or I could do positive 1, negative 9. Okay? Which ones of those is going to give me the positive 8? Negative 1, positive 9. That gives me positive 8 when I add them together. So I'm going to have minus 1 plus 8. Now, if I go back over to Desmos, oh, I don't know why I put an 8, sorry. And it won't let me erase. So I've got to make a mess of this. That's supposed to be a 9. Thank you. And so if I go over to Desmos, and if I type this in, 2x squared, x minus 1, x plus 9, see, it is also the same graph, but I've broken it down further. So this is what Delta Math is going to want you to plug in. Okay? Questions there? All right, we're going to do one more together, and then I'm going to let you guys work on some Delta Math a little bit, because we're going to work on this today and tomorrow, because I think everybody's getting a little tired of sitting here. So let's do example 8. Angel, what's the greatest common factor for that one? What could I divide all of them by? 3. So, can I take any x's? Okay. What's the lowest? First of all, do they all have x's? So if they all have x's, I can definitely take at least an x out. What's the lowest number of x's you see? Just a single x right here. So x can be taken out of all of them. So I have 3x. And then 3 divided by 3 is 1. I had 3 x's. I took 1 away. I just have x squared left there. 21 divided by 3 is 7. And then I'll have just the x right there. And 36 divided by 3 is 12. And the x's just cancel away there. Let's check. I mean, it's a good idea to check on Desmos to make sure you haven't messed up. You're not done, but I want to make sure I haven't messed up. So I've got 3x to the third minus 21x squared plus 36x. And then let's see, 3x times x to the second minus 7x plus 12. Okay, not done, but I haven't messed up yet, right? That part's right. Okay, so we got to keep going, Angel. We can break this into 2 sets of parentheses. Okay, what could I multiply together to get x squared right here? X and x, so that goes right here. My last term is 12. Okay, so I could do 4 times 3. I could do 2 and 6. I could do 1 and 12. I think that's everything. But I also could do -4, -3, -2, -6, -1, -12, right? I could do that also. Which ones do I need, positives or negatives? I've got a -7 right here in the middle, and I'm not going to get that -7 if I don't have negatives somewhere. So these are not going to work with the positives. Which one's going to give me -7? -4 and -3. So I'll have -4 here and -3 here. And if I go over to Desmos to check to make sure I have not messed it up, if I type it in, 3x times x minus 4 times x minus 3, all 3 of those graphs are the same, so I've done it correctly. So that would be that'd be what I type in. Okay, we're going to do a few more of these problems. Let me look at my assignment here real quick. I may change the assignment itself a little bit. Let's see. No, we're fine. Okay. All right. So, if everybody will go to Delta Math, there is a 3.2 assignment. We're just going to work on it for a little bit and see how we can do. Okay. If you would like to use the whiteboards, I find them very helpful for this because there's a lot of erasing and trying different things sometimes. So if you want to use the whiteboards, there should be one under your desk. If there's not, I can find you one. And you can just grab a marker and an eraser from the boards around the edge if you would like. But we're just